Hi everyone, this information is going to be going through oxygen consumption patterns. So looking at how our oxygen consumption patterns change during exercise and some key terms associated with those changes. So we're looking at how much oxygen the body is using per minute at different stages of exercise. Okay, so previously we've looked at our acute respiratory responses to exercise. And we know that there's an increase in our respiratory responses to help meet that increase in oxygen consumption that's happening during exercise so that we can have the ATP requirements met. Our aerobic system initially is unable to respond quick enough to these demands of exercise. So when we start to exercise, we have an increase in our ATP demand. And initially, it's too hard for our aerobic system to be able to get working at a rate that is quick enough to supply enough ATP to meet those demands. So what the body will do initially is work anaerobically to resynthesize ATP. Okay, so if we're going to look at analysing this graph is a really important graph that you need to be able to draw. You need to be able to label it, and you also need to be able to explain it. Other types of questions that we've had in relation to this graph on exams in the past include a description of a passage of play, such as running a 1500 metre race, and then drawing what the oxygen consumption patterns would be throughout that event. Okay, so some key things that we'll look at our oxygen consumption patterns. So this line is our oxygen consumption. Looking at this area that we call oxygen deficit, looking at this area that we call steady state, and looking at this area that we call epoch. Okay, so I'm going to go through each of those components. First one I'm going to go through is oxygen deficit. So when energy is supplied by our anaerobic energy systems, so when we rely on our PC system and our anaerobic glycolysis system, it's because there is a lag in how long it takes for our aerobic energy system to reach its peak power. So during this lag, the body is in deficit in relation to how much oxygen it needs and what it can actually supply. So you can see at this point, the line represents once we start to exercise, immediately our oxygen requirement is up at this point. Okay, and then when we start to exercise, it takes a little while for our heart rate to increase and our respiratory rate and all of those things. So our demand is a little bit lower. So this is what our demand is up high and our what we're delivering is lower. So you can see that there's this gradual increase in the oxygen that we're delivering to the working muscles. So this space highlighted here is what we call oxygen deficit. We need to be delivering this much oxygen, but we're actually only delivering this much oxygen. Okay, so this is the gap between what we need and what we can actually deliver. So during this time, we are relying on our anaerobic systems to create ATP for energy, for our muscle contractions. This occurs because of that our respiratory, our cardiovascular systems, they take time to adjust to that sudden increase in oxygen demand. So we go from being down here at our resting oxygen consumption to up here at our working oxygen consumption. And that instant change in demand, it takes time for our systems to adjust to this demand. Okay, so it takes time for us to increase our respiratory rate, our tidal volume, our heart rate, our stroke volume, etc., etc. So that's why we work in oxygen deficit initially when we start to exercise. How long we spend in this period, so how long we actually spend with our deficit being this large, and the size of this depends on how hard we're working, our training status, those sorts of things. It depends on what sort of exercise we're doing. So if we're doing aerobic work, it can be easier for us to meet the demands of the exercise. If we're doing anaerobic work, that's higher intensity work. It can be harder for us to meet the oxygen requirements, so we have a greater oxygen deficit. Strength-based work is similar as well in terms of how much oxygen we're having to deliver to certain muscles for that particular work. The higher the intensity of work, the larger that deficit is. If it's short duration, then we have a smaller deficit accrued. And if we are highly aerobically trained, our deficit will be smaller. So we can meet the demands quicker, which means we spend less time in oxygen deficit. Once we meet our oxygen demands, so our heart rate, respiratory rate, all of those things have caught up and delivered enough oxygen to the muscles that's required, we say that we reach steady state. Okay, so our oxygen consumption will plateau. Okay, so a flat line like this on a graph, we're going to say that that is a plateau. And that's an important term that you should be using to describe steady state. There's a plateau in our oxygen consumption levels. This is possible because we're relying on energy from our aerobic energy system. So how long it takes to reach our steady state is determined by how hard we're working, our fitness levels, all of those sorts of things. And this can occur at various stages during exercise. So it might be that we might reach, say, this steady state, and then we have to, if it's the beep test, work that little bit harder because we go to the next level on the beep test, okay? And then you would find there would be another oxygen deficit until we meet that new demand, okay? And you would have this step sort of pattern in terms of our oxygen consumption patterns. From steady state to exercise, the reasons that our oxygen consumption can increase is that we increase our intensity. So just spoke about going from rest to working. That's an increase in intensity. So we have this oxygen deficit followed by an oxygen steady state. If we're working in hot and humid environments, it can be harder to meet the demands because we're also trying to thermoregulate. Or if we're maintaining exercise intensity for a long period of time, then that can lead to changes in our oxygen consumption patterns. Our third thing we need to know from this graph is something called EPOC, and this is a perfectly fine abbreviation for you to be able to use. I'll note that your textbook says EPOC or oxygen debt. Please ignore the terminology oxygen debt. Okay, so that's old terminology, and it's more accurately referred to as excess post-exercise oxygen consumption, or EPOC. Okay, so for some reason in your textbook it's got this old terminology that we don't need to be using. When you finish exercising, you don't automatically return to those resting levels. So at the end of a running race, you're still puffed afterwards, okay? And that's because of this concept of EPOC. And this is a good thing for our body. So some people finish a race and they don't want to appear like they're puffed, and they try and hold it and try and breathe normally, and it's very difficult to do because what your body is trying to do at this point in time is actually repay the deficits that you accrued throughout an entire event. So at the start of exercise, you have that oxygen deficit. When we finish exercise, we actually repay that deficit. So we need to keep getting more oxygen to those working muscles to help essentially reset our muscles to resting levels. So returning oxygen back to red blood cells, helping return our muscle fuel stores and those sorts of things. Okay, so we would describe EPOC as the volume of oxygen used during recovery in excess of resting levels. So as soon as we finish exercise, so at this point in time, this becomes our new oxygen demand. Okay, so back to resting levels, we have a low oxygen demand, but we don't immediately return to those resting levels. So our oxygen consumption actually remains elevated. So this EPOC, we are consuming this extra oxygen that's not actually required for the demands of rest, but it's required for a range of other things. It's going to help us resynthesize our PC's fuels. It's going to help us restore oxygen back to our myoglobin and hemoglobin, and we'll look at those two things when we look at muscular responses to exercise. Helps us resynthesize our muscle glycogen stores, helps with removing lactic acid, any hydrogen ions that might have accumulated, removing carbon dioxide, help us regulate our body temperature, all of those sorts of things. So the reason we have this excess consumption post-exercise is that it allows us to do all of these things. So it's a really important thing that our body does. Things that we can do to reduce how long or the size of that epoch before an event, so before an exercise bout, we can ensure that we have a lower body temperature. Okay, so things like hydration can help with that. Acclimatization, so if you're exercising in a hot, humid environment, spending some time training in that environment can help reduce the size of the epoch later on. Work at a lower intensity, so have less oxygen deficit throughout the exercise, or improve our fitness levels, so do more aerobic training. Post-exercise, if we want to decrease our epoch and recover quicker, things like an ice bath can help with that, so that we're lowering our body temperature, rehydration, sitting in the shade, having rest after exercise, or ensuring that we're familiar, so that acclimatization ensures that we're actually used to that environment, so we're not also recovering from that additional factor. If we look at different exercise intensities, so you can see that for low to moderate intensity exercise, we might have an oxygen deficit of this size, but if we increase it to maximal exercise, you can see that we have a much larger oxygen deficit. Okay, so we spend in low to moderate exercise more time in steady state, whereas in this one there's very minimal time, if anything, spent in steady state. Consequence of that, you can see that the oxygen uptake levels are very different, so this is a much larger oxygen uptake across that entire duration of the event. And the biggest difference would be our epoch, so we've got a relatively small epoch here, and a much larger epoch if we're working at maximal intensities. So pretty much if we're working at higher intensity exercise, we have a larger oxygen deficit and it takes longer to reach steady state. We have a larger epoch, which means it's going to take us longer to recover from that exercise bout. If we're looking at our consumption patterns across a 3-kilometre race, and this is when it doesn't follow that neat pattern that we've got in these sorts of graphs. So you can see initially we've got this anticipatory rise. We start to exercise and we have this period where we're increasing our oxygen consumption quite rapidly. So our oxygen deficit would be this, let's go back, would be this period of time. Okay, so looking at what's happening, that's our oxygen deficit where we're not meeting the demands. Once we meet the demands, we've got steady state here. And then it could be that they have to run up a hill in the cross-country course. Okay, so that would mean we would have another oxygen deficit occurring here. Okay, and then they meet the demands of that exercise. Then maybe they're running back down that hill, so it becomes a bit easier. And then they're back at this steady state, and then the sprint towards the end, we have another increase in our oxygen consumption. Okay, and then anything that is below this level would be our epoch post-exercise. Okay, so you can see that oxygen deficit is not just at the start of exercise that it's occurring. In this one, we've got 2 additional oxygen deficits. All right. If we were to look at a 400-metre race, you would be able to get an idea of what the oxygen consumption patterns look like, the fact that he probably wouldn't reach steady state and would have a large epoch post-event because he spent most of the event in oxygen deficit because most of the event he's relying on his anaerobic systems. Things that you need to be able to do, so if we're performing an activity at a lower intensity, that means we're going to have a longer steady state, and the effect of that is going to be a smaller epoch post-exercise. During activities, when we reach steady state, and then we have to sprint or go up a hill, that also adds to the oxygen deficit across the event, which increases our epoch during recovery. If we do aerobic training, it means that we can reach steady state earlier, so there's less time spent in oxygen deficit, which means you'll have a smaller epoch during recovery. Less time is spent relying on those anaerobic energy systems, so reaching steady state earlier, having small oxygen deficits, means that we recover much quicker post-exercise. Okay, so there's some examples of questions that you might be able to do for different types of things in an exam situation. So identifying the predominant energy system at different stages of a run, and then drawing a graph that shows this, and therefore it shows our oxygen consumption patterns during that event. Or it could be creating a graph that shows the difference in a trained and untrained person and how they respond to exercise during an event. Biggest thing would be being able to compare a trained and untrained person. So you can see that if they're working at 100% intensity, the untrained person, they might be only able to get 120 litres per minute with their ventilation, whereas a trained person, they might be getting 220 litres per minute. That means they're going to be able to work at a much higher intensity aerobically, which has great benefits to that performer because they would have smaller oxygen deficits throughout that event, more time spent in steady state, and therefore a reduced EPOC post-exercise. And that would be going through our oxygen consumption patterns. So that links in with our respiratory responses to exercise that was looked at previously, and we'll look at this further when we start to look at fatigue and recovery during events, and also how we can improve our aerobic power.